So the talk is about some work that we did in the context of Singapore, and the FRS2, which is a collaboration of ETH, NUS, and NTU, which is called CREATE. This is a building especially in Singapore. And so the collaborators of this project were the two postdocs, Bertrand and Jean Davids. And the professors were here, Xiu An Chong from Nanyang Technical University, and Renate Schubert, who is a colleague of Dirk. She is emeritus from ETH and works at DGES, a sociologist. So she is presently in Singapore, but she is actually an emeritus of ETH. So that's the group. And so the subject is social resilience. What is social resilience? There exist two interpretations. You can either be as an individually social resilient. That's not what I'm going to talk about, but I'm going to talk about the resilience of a society. So how a society can recover from some bad event. So there are many possible examples. You can imagine wars or earthquakes or tsunamis or whatever, which will disturb society and destroy many social links. And the question we ask is, how do these social links recover? How does the society, the social, let's say, texture really come back? And one of the possible, let's say, disasters that can happen are lockdowns. And this is the one that I'm going to talk about, because this is the one for which we do have sufficient, let's say, ways of experimentally verifying our model. So the challenge, what I'm going to talk to you about, is to make a model to describe this social resilience and then to verify this model with some data. In fact, the talk will be divided, it's about 3 papers, it will be divided in 3 parts. The first part will be the social resilience model for one community. The second part will be the 2-community model, and the third part will be the validation of the data. So let's come to the model. The model is based on a classical model of Herrmann and Newman, a social network model. And so we have a certain number of individuals, and between individuals we have connections, let's say knowledge, friendships or contacts. And these contacts are formed by 2 possibilities: either a random contact, that randomly you create a contact between 2 people, or you can have social contacts, which are contacts that only occur when both persons have a joint knowledge. I mean, there's a third person that both of them are connected to. And this is what we call social contacts. And so there exists a rate R0 for the random contacts and a rate R1 for the social contacts. And then there is a third parameter in the game, which is the breakup rate for contacts. So contacts can be formed and can be broken again. And finally, another detail is that we have a maximum degree of possible contacts per individual. There must be, otherwise it will run out of hand. So that's the basic model. Here comes a more technical transparency, which I will not discuss, because how exactly to implement these rates, this is maybe too technical. And then, of course, you can start with any random starting configuration, evolve the system, and you will attain after some time, a short time, a steady state. So as I said, what we want to model is the effect of a lockdown. And so a lockdown will be now defined as a time during which these rates of forming random or social contacts will be reduced by the strength of the lockdown sigma. So the lockdown has 2 parameters, the strength and its duration. So we implement this model and obtain now time evolutions that look like this. So you see that here is the beginning, this is the end of the lockdown. You see during the lockdown, the number of edges decreases dramatically. And then there comes after that a recovery. And this recovery can now be fitted by an exponential. And so you get some expression like this. And this time that here appears here, the recovery time, is now a measure for the resilience of this society. In fact, it's the inverse time which is proportional to, or which relates to the quality of resilience. The larger the time is, the less resilient is this society. And so this tau will be the measure how well let's say, measure the strength, the resilience. So there's now some details. So on one hand, one can see that this recovery time within error bars is independent on the system side. So this is a good news. And then here, this is interesting. How does this recovery depend on the properties of the lockdown? So here you see now lockdowns of different duration, and you see there's very little difference. So the duration of the lockdown does not matter very much. But this is now a function of the strength of the lockdown. You see that if you increase the strength of the lockdown in the beginning, for small strength, you have a very strong effect in the, let's say, recovery time, but then there will be a maximum. That means after a certain amount of strength, if the lockdown is too strong, then the effect on the recovery time will be not visible anymore. You have potentially a given recovery, which is the recovery that happens after a very, very strong lockdown. So this is like this value of T infinity 61. And then you can also study how does this recovery time depend on the parameters, on the rate of social and the rate of random contacts. And what you see is that this is now dependent on the rate of social contacts, that the recovery time does actually not improve very much. It's worse. I mean, if you make more social contacts, the recovery will be more difficult. While on the other hand, this is what is the main result of this first paper, is that if you change the rate of random contacts, the recovery time is extremely strongly influenced. And in fact, the relation is given by an inverse relation. It means that the resilience of the society is proportional to the rate of random contacts. So the more random contacts you make, the faster you recover. And this seems to be the most important, by far the most important effect. So the social contacts seem to be very, let's say, secondary in comparison to the random contacts. This is the most important result from this first work. Then these are then other details, how it depends on the breakup. I don't want to go into too much detail here. And this is another detail, how it depends on the maximum number of degree of individuals. So the second work I want to talk about is now what happens when you have two communities which are different by anything. They could be different by gender, or different by their social standing, or by their age, or by whatever you see, religion or culture. So any distinction we have, you have a community which consists of two parts, yes, and you want to see how important is the connection between these two communities for the recovery of the society. So this model has now two additional parameters. One is called alpha, which gives you the proportion of inter-community contacts with respect to intra-community contacts. So if alpha is 0, the two communities are disconnected. And if alpha is 1, then only connections exist between the two communities and not within the community. And oh, what's happening here? Oh God, sorry, something has happened. You have to go back? No? Forward, forward, yeah. I did something stupid. Okay, go back. Okay, so and then there's a second parameter called beta, which tells you how different the two communities are. And since we have seen that the main difference comes from the random contacts, we will focus only on them and say that beta equals 1/2 means that both communities have the same rate of making random contacts. And if beta is smaller than 1/2, then in one community, community 1 has more random contacts than community 2. And if beta is larger than 1/2, then community 2 has more random contacts than community 1. So this decides how much random contacts each one has. And in this model, one can, of course, again, simulate time evolution for different parameters. And one can in particular see, one can in particularly see that each community has now its own recovery time, if they are different. Yes, and so depending on how different they are, I mean, the recovery time of the two communities kind of is complementary, and a real recovery time of the system is, of course, the larger one of the two. So the entire system recovers when both of them are recovered, and this is what you see here as a function of beta. This is the largest one of the two. But mostly when you have these two different communities very different, then each community has its own recovery time, and the overall recovery can be described as a combination of two exponentials, yes, and each, as I said, this exponent, each time corresponds to another community. Now, this is a detail. Now, this is the most important result of this second part, namely that systematically the resilience, which is 1 over tau, increases with alpha. So the more the two communities are connected with each other, the higher, the better is this resilience of the society. So this is the most, repeating, what is crucial are the random connections, and what is crucial are the interconnections between communities. And now, after that, this is another detail. I will come to the last big question, which is now the trying to verify this model with real data. And for that, we did a survey. I think this is actually the first time I've seen that one does this kind of thing with a model, but actually. So we did a survey, not we did a survey, but I have a company called Qualtrics that did a survey in Singapore with 2,000 individuals. And this is here paper, which is not yet published. This is submitted. And in this survey has first a part which is demographic. So this showed first all the data about the society, about what their school and about religion and the culture and the employment, blah, blah. So you have all this demographic data about some of them are Chinese or Malay, and how much their income and how many children they have. So this is all just demographic. And then we have a bunch of questions which are related to the communication that they have with other people. And there are these crucial questions here, which I will discuss in a minute. So most communications were done with WhatsApp. As you can see, WhatsApp was the most important used communication tool. This is how mostly of the breakups occur. It's also detailed. And this is how now the pandemic's evolution in time, you see this is here, the alpha version, delta, omicron. And here you see this is the time at which we did the survey about the last 6 months, which is the gray zone. But the gray zone was divided in 2 units of each 3 months, as you can see here. And then we have questions asking how many new people you met in this time, how many people left, and how many contacts you lost, etc. So these are the questions. Like in detail, the questions are given here, which of course I'm not going to read. And then each question could be now composed by knowing the number of people that the contacts that you got or you lost, and using the questions that you had, one could then relate the questions to these numbers. You get a system of equation that you solve for the parameters of the rates of this. And then you can solve this and you get now an expression of the parameters as function of the answers of the questions. And at the end, after doing a lot of stuff, you can get my parameters out of these surveys. And then you can simulate this again with using these parameters. And you find that indeed, as observed in the survey, the recovery time is about 1 to 2 months. So we see that, and actually we see that this is a rather stable result, because if you change the parameters a little bit, you don't find much of a difference in this sense. And the only really parameter that matters is R0, and actually that even does not change very much this time. So summarizing, one detail more. We also looked at 2 different communities at 2 different ages. So everybody below 40 and above 40 are 2 communities. And then we could actually, by the questionnaire, which said who is friend with which age, we had an age question, we could then obtain also the beta and the alpha of this model. But what we have not yet done is the simulation of this beta and alpha. So summarizing, we have learned a lot about how to improve our survey. I mean, this will next time we'll make it better. But the main results are that random meetings are more important than social meetings, that the communication between communities is the most important factor for resilience, and that we can reproduce the information that in Singapore, the recovery of the social network was of the order of 1 to 2 months. Thank you very much.